pressure ranges as low as 3 inches of water to as high as 2 lakh size. Inaccuracy ranges from 0.1% of span to 0.25% of full scale. Then another example is RTD. RTD means a resistance temperature detector. Resistance temperature detector devices are conductors used for temperature sensing. They can be used in bridge method as well as ohmmeter method to take the output. The change in the resistance of material per unit change in temperature should be as large as possible. The material should have high value of resistivity to get required value in less space. So, within small change in the value of temperature, there is a high change in the value of resistance. Resistance and temperature relation should be continuous and stable. So, as well as whenever there is a change in temperature, there must be a change in the resistance. Platinum, nickel, copper are the most commonly used type of materials for RTDs. Sometimes tungsten and nickel alloy are also used. Applications of RTD, they can be used in average and differential temperature measurement. Differential temperature sensing to an accuracy of 0.05 degree centigrade have been accomplished in a nuclear reactor coolant heat rise application. So, these differential temperature measurement type of RTDs are used in nuclear reactor coolants when there is a rise in the heat. Second type of transducer is variable capacitance type of transducer. A capacitance is a pair of parallel plates with some insulating dielectric material between them, and this dielectric material is used to store an electrostatic charge. Capacitive transducer is a passive transducer, so they require external supply for their operation, used for sensing displacement. They are generally used for sensing displacement, or sometimes they are used to measure the liquid level, etc. It is a primary transducer. Capacitive transducers sensors are extensively used in industrial and scientific applications. They are based on changes in the value of capacitance due to change in physical variations. So, there are some physical variations due to which there is a change in value of capacitance, which is calibrated against the input quantity. These sensors find many diverse applications, but main are related to the measurement of displacement. So, main application of these type of transducers are related to measurements of displacement. These are the various type of capacitors used in the capacitive type of transducers. Capacitive transducers measure the displacement by measuring the change in capacitance. The relation we get is C is the value of capacitance in farads, is equal to insignia A upon D, where insignia is the dielectric constant, A is the area of cross section of plates, and D is the distance between two plates in meters. So, A is the area, cross section area in square meter, D is the distance between two plates in meters. That means, there is the change in the value of capacitance due to change in overlapped area of plates. When there is change in the area of plates, there is change in capacitance, change in distance between the two plates, change in dielectric medium. Any three of these parameters may change the value of capacitance. Capacitance may be changed either mechanically or electronically. The variable capacitance used to convert physical phenomena into electrical signals is called as variable capacitor type of transducer. As there is no movable contacts, there is no wear and tear, and the life expectancy quoted is near about 200 years. But the major problem of these type of transducer is their high impedance, which makes them very much susceptible to noise. So, they are very much affected by the noise. Advantages of capacitive transducer: they have low hysteresis, which is a main requirement of any type of transducer, good linearity, high sensitivity, stability, repeatability, resolution as small as 0.003 mm can be obtained. So, this is very well said, and static pressure measurement capability. So, these all the advantages are according to the our requirements for a good transducer. But as well there are some disadvantages of this type of transducers are also, that is high impedance output, high temperature sensitivity, they are very much sensitive to temperature change, need for complex electronics, their circuits are somewhat complex, dirt may vary the output, due to the dirt the output may vary. There is another example of capacitive transducer for thickness measurement. Capacitive transducers can also be used to measure the thickness of the material. This method of measuring thickness is used in case the material to be tested is an isolator. So, there is a requirement that in case of thickness measurement, the material whose thickness is to be measured must be a insulator. Material whose thickness is to be measured is placed in between two metal plates, forming a parallel plate capacitor. So, by using that material that is placed between two parallel plates, we form a parallel plate capacitor. This is example. These are two plates in which there is a dielectric sample whose thickness is to be measured. According to that relation, as the C is equal to insignia A upon D, as any of these three parameters, for example, A or D, A means area of cross section of plates, D is the distance between plates. So, the thickness means the distance between two plates. The material we used is placed between two plates. According to the material used, according to the thickness of material, the distance between two plates are changed, and due to the change in the distance, there is a change in the value of a capacitance. Another example of capacitive type of transducer is for liquid level measurement, that is dielectric gauge. Capacitive transducers can be used in liquids and free flowing solids for continuous liquid level measurement. Materials placed between the plates of a capacitor increase the capacitance by a factor insignia known as the dielectric constant of the material. When two capacitor plates are partially immersed in a non-conductive liquid, the new capacitance C D is given as C A into dielectric constant into D plus C A divided by R, where C A is the capacitance without liquid, this is dielectric constant, D means the depth of the or the level of the liquid between the plates, again C A is the capacitance without liquid, and R is the height of plates, and C D is the capacitance when the material is immersed in a liquid. There are large variations in dielectric constant with temperature. So, temperature corrections may be needed. So, this is one of the main disadvantages. It is very much sensitive to temperature. The capacitive type of transducers are very much sensitive to temperature range change. So, in this case there must be a temperature correction. The liquid level is given by D is equal to C D minus C A into R divided by dielectric constant into C A. This type of sensors or liquid level dielectric gauge are widely used for chemical and petrochemical industries and can be used for wide range of temperature, that is minus 40 to 200 degree centigrade, and pressure variation, that is from 25 to 60 kg per centimeter square. Third type of transducers are variable inductive type of transducers. Inductance is another property of electric circuits which can be used in transducers. If a length of wire is wound into a coil and an electric current is passed through it, a magnetic field is generated, that is electromagnetic induction. And if this the applied current varies, the magnetic field also varies, and this induces other currents in the coils. Due to change in the applied current, there is change in the magnetic field which induces other currents in the coils, which tends to oppose the original. The new induced current tends to oppose the original current. This property of a coil is known as self-inductance. Self-inductance is a measure of this opposition, and it is given by L. L is equal to N square mu 0 mu r into A divided by L henries, where N is the number of turns of the coil, A is the cross sectional area of the coil in meter square, L is the length of the coil in meters, mu 0 is the permeability of free space, that is 4 pi into 10 to the power minus 7 Henry per meter, and mu r is the relative permeability of the material used, the magnetic material we used. So, with all these parameters, there is change in the inductance of the coil, whereas inductance is a property due to which it opposes any change in the current of the coil. One of the example of inductive type of transducer is LVDT, linear variable differential transducer. LVDT is used for measurement of displacement. It is a passive transducer, so it requires external supply for their measurements. Supply is provided to the middle coil and output is taken across the other two coils. So, there are three coils, one is middle and two are on the sides. Differential amplifier is used to measure the differential output from the windings. Out of these two side windings, the output is taken as and given to differential amplifier, which gives us a differential output from the windings. The output is an AC waveform. This is a diagram of circuit diagram of LVDT. There are three windings. These are two side windings, and this is middle winding, and to middle winding we are giving a supply, and output is obtained from this two side windings, which is given to a differential amplifier, and this core is movable. This core is movable, whose displacement is to be measured. Why we use LVDT? LVDT, there is a friction free operation because there is no mechanical contact between core and coil, infinite mechanical life, infinite resolution, that means electromagnetic coupling. The limitation is only by the external noise, electrical noise, low risk of damage, there is very low risk of damage, and most LVDTs have open bore holes, null point repeatability, that means zero displacement can be measured, single axis sensitivity, effect of other axes are not felt on the axis of interest, environmental robust. So, this is a diagram, there are three positions, that is middle position, maximum left or maximum right. In case of left, the E1 is greater than E2, in case of right, E2 is greater than E1, and in case of middles, when the core is in the middle, their output is 0. Advantages of LVDT, their measurement resolution is almost infinite, negligible hysteresis, high signal to noise ratio, low cost, no damage to the LVDT. Disadvantages, there is present of harmonics, stray capacitance also present. The core must contact directly or indirectly with the measured surface, which is not possible or desirable. The summary is that there are some other types of transducers also, which are basically such as solid state temperature sensors, pulse width modulators, thermocouples, piezoelectric transducer, photoelectric devices, bimetallic thermometers, ultrasonic flow meters. Thank you.